define an exponential function, this is exactly what it is. It's a function that can be described by an equation of the form y equals ab to the x, where a doesn't equal 0, b is greater than 0, and b can't equal 1. So let's think about things. A can't equal 0. Why can't a be 0 in that function?
Because then the answer would be 0.
Because then the answer would be 0. Right. If I put a here, I'm just going to get y equals 0 for everything. So that's why it can't be 0. It can be anything but 0. It could be a negative number. It could be a positive number. It could be a fraction. Okay? B is greater than 0. So tell me what that means.
It's a number greater than 0.
It's greater than 0. What else about it?
It can't be negative.
It can't be negative. It's got to be a positive, right? So it can be a fraction, though, but it just has to be positive. So no negatives are allowed for b. And then b can't equal 1. Why couldn't it equal 1? It'd just be the same number. That's right. If I have 1 to x, that means 1 to any power. It'd just be the same number. So these are some examples of what exponential functions look like. And so today what we're going to do is we're actually going to graph those. So let's go ahead and look at this one. It says find our graph y equals 3 to the x. Find the y-intercept and state the domain and the range. Okay, so when we graph these, we're going to use an xy chart. Okay, so, or a t-chart, you might have heard it referred to. But that's what you're going to do on every one of these. We're just going to make an xy chart. The three numbers you're going to let x equal are -1, 0, and +1. Now, if I let x be -1, if I plug it into y, I get 3 to the -1 power. What is 3 to the -1 power? 1/3, right? Because that's like a fraction. So my ordered pair is at -1, +1/3. So how do you graph +1/3 up? You just put it about 1/3 of the way up. Okay, let's plug in 0. If I plug in 0, what do I get?
1.
I get 3 to the 0 power, which is 1. Anything to the 0 power is 1. So this ordered pair is at 0, 1. All right, let's plug in the next one. What do I get here? 3 to the what? First, which is 3. So my ordered pair is at 1, 3. Now, a little bit about exponential functions. They are curves. They are not lines. The other thing is they will never touch a certain line. They've kind of got a limiting factor there. And so what that means in this case, it's not going to touch that x-axis. Okay, you see kind of how that looks? It's not going to touch that x-axis. So make sure your line doesn't touch. Make sure it has arrows. Now we've got 3 things we need to find. We need to find the y-intercept, the domain, and the range. So the y-intercept is what? 1. It's where it intersects the y-axis. Now you might notice you get 1 a lot, and that's okay. Right? The domain, remember the domain, that is our set of x's. That is like left to right. The domain on almost all of these will be all real numbers. You can plug every number in there and get an answer. So you're probably going to answer all reals on today's assignment, and that's okay. The range, on the other hand, what was the range? Do you remember what the range was?
You subtract the
Well,
lowest.
Okay, remember the domain was the set of left to right, the x's. What's the range? The y's. The range, remember, was up and down. And so if I look at this, where did I say was going to be the lowest value? Do you remember in this graph? What did I say it will never go below? The x-axis, right? And so basically, I'm just looking for values above that. So I want to say that y, because that's my range, is greater than what number? 0. But it won't equal 0, because if it equals 0, that means it'll touch the line. Alrighty, let's try another one. Okay, this is y equals 1/3 to the x. So once again, we're going to make an xy chart. -1, 0, +1. So let's go ahead and plug in -1. So if I take 1/3 to the -1 power, what number does that give me? 3. Good. So I have an ordered pair at -1, +3. Okay, so this one will be 1/3 to the 0 power, which is what? 1. Okay, so I've got a dot at 0, 1. What about the next one? 1/3 to the first, which is 1/3. So I have an ordered pair at 1, 1/3. So what's different in this graph? It goes down instead of going up. So once again, let's go ahead and draw that in. I've got 3 things again I need to answer. What's the y-intercept? 1. Remember what I said. Probably going to answer that a lot, and that's okay. Domain. All real numbers. Okay, it goes to the left and the right. What about the range? Y is greater than 0, right.
When will the domain be different than all the numbers?
Probably not on anything on your homework for today. Okay. Not on the exponential functions. Generally, the domain will be all real numbers. There will be instances of where a function like wouldn't go all the way to the left. An example of something like that, and you probably won't see it today, would be a graph that might go like this only. Okay, and it would never cross that y-axis. Okay, but we'll get to those later on. Okay, but today, generally, it's probably going to be all real numbers. So let's go ahead and look at this one. Now, remember what I said, I've got a little bit of a change. Okay, this one is y equals 5 to the x plus 2. And notice I moved my axes down here. Okay. So we're going to go ahead and do x and y. -1, 0, 1. So if I plug in -1, I get 5 to the -1st plus 2. What's 5 to the -1st? 1/5, because remember that negative means it goes to the denominator, guys. I'm going to add 2, and what do I get? 2 and 1/5. So I'm going to graph at -1, 2 and 1/5. So once again, on the 1/5, just go ahead and approximate. Huh? Yeah, you can. Okay, I'm sorry, they're going to be, it's going to be harder for you on this one because I even shrunk them down a little bit more. You could even probably draw a new graph if you wanted. So on this next one, I get 5 to the 0 plus 2. What's 5 to the 0? Plus 2 is 3. So I've got a 0, 3. This next one will be 5 to the 1st plus 2. So your answer is 7. So I've got a dot at 1, 7. Okay, so you remember how on the last ones they never crossed the x-axis? Remember how that's where we said it limited out? Do you think I've got something like that here, or do you think it's changed? It's changed, okay? So what do you think it's moved to?
Two.
It's moved to what?
2.
2. Okay, you're actually right. And so this is what my graph should look like. Now, if you're a little bit hazy on the 2, just hold on. We'll talk about it in a little bit. Let's go through the y-intercept first, and let's go through the domain next. Okay? Y-intercept is what? 3. What's the domain? All rails again. Now the range is what's different. Okay, because if you remember on the last ones it's been y is greater than 0. What do you think it's going to be now? Y is greater than 2. Now, if you're wondering, well, how do I know it's 2 and not 1? Is there something maybe in the problem that would tell me it might be 2? The plus 2. Exactly right. This is going to be what kind of is your hint as to what your value is. So whatever you're adding on, that's going to be used in the problem with the range and with that kind of limiting area. So let's go ahead and look at the next slide. This basically, there's not a lot you need to understand here except for the fact growth goes and decay goes down. Okay, so growth goes up, decay goes down. And there are some different characteristics of each. We will get into that more, especially in Algebra 2. Okay, so now it says determine whether the set of data shown displays exponential behavior. Write yes or no. Explain why or why not. So first of all, I want you to look at all these x's. What am I doing every time with the x's? I'm adding 5. Very good. So now what I'm going to do is I'm going to look at the y's. What does it look like I'm doing with the y's here? I'm dividing by 2. So each y value, I am dividing by 2 to find the next one. Okay, now this is your key. If you multiply or divide by a number, that's going to be exponential growth or decay. If you add or subtract a number, that is not exponential growth or decay. Okay? You are always looking at your y's. Those are what you're looking at. So based on what I just told you, would this display exponential behavior? Yes, because I'm dividing by 2. And then if you want to do this, you could just do that. Okay, you're dividing by 2. That to me tells me that you understand the multiplying or dividing displays the exponential behavior. Yeah?
It has to be on y, not x.
Yes.
So
Has to be on the y. Yes? The x does not matter. The reason why I had you look at the x is because you want to see that it does the same thing in intervals of 5. So like if we would have went 0 to 5 and then like this would have been 5 to 15 and this would have been like 15 to 30 and then these would have all been divided by 2, that wouldn't have quite been exponential behavior because these weren't the same intervals up above. Okay. So let's look at this next one. How many people think this displays exponential behavior? How many people think this doesn't display exponential behavior? Ooh, the majority of you say no. Why? Because what are you doing every time? You're adding 4. Good. So, no, this does not display exponential behavior. Why? You could just put plus 4. And that would tell me enough. So any questions over that? We do have a change in your assignment. It is not 10 through 18 the evens, folks. It is now 10 through 18 the evens, 21 through 24. Okay, so that is a little different based on what you have written. Okay, 10 through 18 the evens, 21 through 24 all.